Welcome to STEM Kits from iBio Institute. Today, we will be investigating a technique for separating molecules in a solution that's called gel electrophoresis. You will build a simple gel electrophoresis chamber that you will use to separate food dyes from a solution like they do in forensic and biochemistry lab. My name is Grace, and along with the rest of our STEM Kit team, I will be guiding you through this investigation into the ways we can separate mixtures. Doing an investigation scientifically is different from just playing around. Scientists conduct their experimentation in a very deliberate way. In chemistry, it is crucial that the methods that are chosen to explore chemical interactions are chosen and ordered carefully. In this investigation, you construct a chamber that will create a complete circuit and use the force it generates to filter molecules in a gel. Like all scientists, you will make careful observations of the gel to determine similarities and differences between the molecules in the solutions. Scientists always record their data accurately so that they can communicate their findings to other scientists. You have a gel diagram in your STEM kit instructions that you can use as a record of your work. Observe carefully and don't forget to write your findings down. A mixture is made when two or more materials are combined, but they are not combined chemically. That means that when you look at the mixture, you can still see each item as a separate thing. You could actually pick them apart and move them into separate piles, like these Legos. But if the mixture is made of small items or molecules, that type of separation would take a long time. An easier way to separate a mixture is by using the properties of each material. Is it magnetic? Is it soluble? Is it heavier? Lighter? With some creativity, these properties will systematically separate the items for you. Unfortunately, this type of separation doesn't work with a solution. A solution is a type of mixture that consists of two or more molecules dissolved in a liquid form, like coffee or juice or soda. Separating molecules in a solution can be tricky. Scientists have developed some techniques that separate the molecules out of a solution. One separation technique is called gel electrophoresis. If we put a small amount of the solution into a gel, we can use an electrical current to separate the molecules as they move through the gel like a filter. The electrophoresis chamber is essentially a plastic tray with a flat slab of gel placed inside the chamber. The gel has small holes called wells, where we put the solution that we want to separate. The electrophoresis chamber has a power supply that creates a circuit of electricity to move the molecules in the solution. The chamber is negative on one side and positive on the other side. The electricity moves in a circle through the gel. But we have a small problem. In order for the gel to filter the solutions, the electricity will need to pass through the chamber. Electricity does not travel through the air, which means that the empty chamber is an incomplete circuit. The electricity cannot get from one end of the chamber to the other. No separation. To solve this problem, we will pour a buffer solution into the chamber. The buffer solution contains charged molecules, and this allows for the current to jump from molecule to molecule and travel through the chamber. Now we have the force we need to separate the molecules in the gel. If we look at the gel used in electrophoresis, we can see that it is filled with holes and passages. When we turn on the electricity, the negatively charged molecules will begin to move from the negative side of the gel to the positive side of the gel through the passages. But you can see that the molecules are not moving at the same speed. The big molecules don't fit through the narrow passages very easily and will move more slowly, falling behind the smaller molecules. The smaller molecules, which fit through the passages easily, will move more quickly up through the gel. This separates the molecules so that scientists can identify what they are. Now that we've learned a little bit about gel electrophoresis, it's time to start our experiment. To build our electrophoresis chamber, we will need a Ziploc, small, square, 1-press container, 2 jumbo stainless steel paper clips, a 3x3 craft foam square, a ballpoint pen, our paper cone pattern, and some scissors from home. The first step in building our gel electrophoresis chamber is to prepare our paperclip electrodes. To do this, follow the steps on this slide to unfold and manipulate your 2 paper clips. If you're having trouble, no worries. On the next slide, you can watch one of our STEM Kit team members show you how it's done.
In order to make the second electrode, first you will need another large paper clip. The first thing you want to do is unfold the paper clip like this into an L shape. Then you want to unfold these pieces and make sure that the unfolded piece that is longer, which is this one, is on top. Then you want to twist this piece towards you so that it looks like this. Twist it down like so. And then twist the bottom part a little bit up again to create a shape like this. And there you have your last electrode.
Once we've bent our paper clips, we will need to fit them to the sides of our Ziploc container, which is our chamber. Hook one bent paper clip over one side of the plastic container so that the bottom L runs along the bottom width of the container. This paper clip will be your negative electrode. You may find that your electrode does not sit in the box well. You may need to take it out and manipulate it further so that it better fits the container. Squeeze the two sides together so that the clip does not wiggle. On the opposite side of the chamber, do the same thing with the second paper clip. This will be our positive electrode. We want our chambers to look like the pictures on this slide. Now that our electrodes are in place, we need to create our comb. With scissors, cut out our paper comb pattern. We will then trace this pattern onto our foam square and cut that out as well. This will be our comb. You will need to trim the comb so that it fits easily into the chamber and hangs without touching the bottom. An important part of our electrophoresis chamber is our power source. Follow along with our STEMKit team member as they show you how to assemble your power source.
Next thing we want to make is a series of 5 batteries. Each battery has a negative and a positive side, which has different shaped ports that stick together in the opposite ports. So positive and negative stick together like that. So to make the series, you have to keep sticking the positive and negative sides together until you have a shape that looks something like this. And there is your 5 battery series.
Pause the video now to assemble your power source so that it looks like the picture on this slide. Nice job setting up your chamber. Now it's time to get our gel ready. With some help from an adult, follow the steps to melt the gel. Once it is melted, place the tube in a glass so that it stands upright while you get your electrophoresis chamber ready. Once the gel is melted, we will need to pour it into our chamber. Be careful, the container and gel are probably hot. Once the gel is poured, place your comb on the chamber so that it is close to one of the sides like you see on the screen. We want the gel to solidify, so let it sit for 20 to 30 minutes until it's firm to the touch and wiggles like solid Jell-O. Pause the video now to follow our procedure for pouring the gel and setting up your comb. We are almost ready for gel electrophoresis. Don't forget that we need a buffer to carry the electricity and move the molecules through the gel. In order to create our buffer solution, you will need to put 30 milliliters of water into our empty plastic tube from part B. Add 1/8 teaspoon of baking soda to the tube, put the cap on, and shake until the baking soda is dissolved. Now your buffer is ready. After about 20 to 30 minutes of solidifying, your gel should be ready. If your gel is firm to the touch and wiggles like solid Jell-O, gently pull the comb out of the gel like you see us doing in this video. This will leave small holes in the gel called wells. This is where we will be putting our samples. Now we will need to make some room for our electrodes. With some help from an adult, use your knife to cut your gel. Be careful not to cut into the wells.
Okay, you're going to make a little tiny cut on one side and a little tiny cut on the other.
Now that we have our buffer, we are going to pour it into our chamber until it is just above gel level. Your gel should be completely submerged. Finally, it's time to add our samples. Follow along with our STEMKit team member as they show you how it's done.
So next we are going to put the solution inside the wells. So you want to use a clean pipette. You put it inside the tube with the solution. You just squeeze it in order to get the solution into the pipette. Next, you take the tip and you put it inside the well without squeezing. Just put it all the way inside. Once you get to the bottom, you squeeze gently. Just put 1 drop into the well. And there you go.
Pause the video now to follow our procedure for adding the samples to the wells.
Now that we have everything set up, we're going to place both of the paper clips into the container. You're going to place one paper clip on one end and make sure it touches the bottom, and then another paper clip on the other end and make sure that one touches the bottom as well.
Now that your gel is all set up with your 3 samples, you will need to hook up the power. With one alligator clip, connect the negative terminal of the battery pack to the electrode nearest the wells. With the second alligator clip, complete the circuit by connecting the positive terminal of the battery to the electrode furthest away from the wells. As soon as you do this, you should see bubbles forming around the electrodes in the buffer as the current passes through them. If you don't see bubbles, recheck the electrical connections. Make sure the batteries are properly placed in series and that the batteries are fresh and fully charged. Pause the video now to follow our procedure for connecting the power source. Now that your power source is connected, your samples will be starting to move. Because they are so small, they will move slowly, so you will need to be patient and give them some time to run. But you should check the progress of your gels every 10 minutes so that you can see what's happening. What do you see the electrophoresis chamber doing? What are the samples doing? Are the samples still in the wells? What do the samples look like right now? Do all of the samples look the same? Run the gel until you see good migration and separation of the food coloring dyes. You will need to wait about 30 minutes. After 30 minutes, unclip the alligator clips from the electrodes. This will turn off the electrophoresis chamber. You will have an easier time seeing all of the colors if you remove the gel from the plastic container. Use your fingers to slide the gel out of the plastic container and into the plastic bag. From the bag, you will be able to see the results clearly. Now you can do some analysis. What color dyes are in each of the samples? Which dyes are the biggest molecules? Which dyes are the smallest molecules? Which dyes are found in more than one sample? You have done such a great job today. You built your own electrophoresis chamber and separated the molecules of dye samples using gel electrophoresis. Awesome! As you analyze your gel, record your results in your packet by drawing the bands you see in color. Compare and contrast the colors you see to determine the different qualities of each sample and the molecules it consists of. Thanks for joining us today on the STEM Kit investigation. STEMKit is a product of iBio, delivering industry-led STEM programs for teachers and students to inspire a new generation of innovators and entrepreneurs. To learn more about iBio and its programs, visit www.ibio.org.